Hello everyone, welcome to our basement. Today we will be sharing with you our knowledge on the beautiful AC motor and its many applications. Today with me I have
Scott Robbins. I will be talking about the capacitor run start motor. It's a beautiful piece of equipment, very commonly used everywhere.
Also with me I have
Craig DeVries, and I'll be talking about the hysteresis motor and its many applications in small devices.
Let's get into it.
Beauty.
AC motors function on the interaction of a magnetic field created by the AC current in the stator and the armature to spin the rotor, creating usable torque. These motors can be found in every category of industry, whether that be in the workforce or in consumer products. The main reason for how common these motors are is because of the low cost it takes to create them, speed variation, and how reliable they are. The low cost is a result of the simplicity of the overall design of most AC motors, which is also why they are so reliable and require such low maintenance. There are many different types of AC motors, such as synchronous and induction, for example, which Scott and Craig will be talking about later on in the video. Induction is the most common of all types and is found in simple spots like vacuums, blenders, or fans. Synchronous motors are found mostly in applications where precise speed control is needed, like compressors or to regulate voltage at the end of transformer lines. As stated previously, AC motors are widely used because of their ability to vary speed by simply changing out the number of poles used. Fans that have different set speeds and use large amounts of AC voltage to produce wind pressure in industry is a good example of where variable speed is desired.
Hello. As Joel stated earlier, I am here to talk about a type of induction motor, the capacitor run start motor. And basically what that motor is as you can see here, it is two capacitors, a start capacitor and a run capacitor, both in parallel with the starting winding. And what that does is it actually chokes the current coming in enough to give us a 90-degree phase shift. And that phase shift is enough to give us 200 to 325% more starting torque, which is great. That application right there is used in vacuums, washing machines, any small appliance. Say if you had a washing machine with a full load and it did not have as strong as a starting torque as the capacitor run start motor, it wouldn't have enough torque to even start the load to get it going. So that's why this motor is used to start it every time, no ifs, ands, or buts. Also, this motor with the start capacitor gives it a great efficiency rating. But unfortunately, because how efficient this motor is, it costs an average of 100 to 115% more than a normal three-phase squirrel cage induction motor. Another interesting thing with this motor and the setup is the start capacitor is only used for the start, hence the name. It is hooked up with this centrifugal switch, and once the motor gets to 70 to 80% full speed, the centrifugal switch will open as it is now and will cut power to the starting capacitor, just leaving the run capacitor open for optimal efficiency.
A hysteresis synchronous motor consists of a wound stator producing a rotating field, and also a rotor in the form of a cylindrical shell with crossbars made from steel with high magnetic hysteresis. At startup, the combined effects of eddy currents in the steel cause induction motor action and remnant magnetism in the steel, which causes the magnetic poles to follow the rotating field and causing the motor speed to build up. As the motor approaches synchronous speed, the magnetic effect of the crossbars behaving like a permanent magnet causes the motor to lock on to synchronous speed. The cylindrical stator structure is identical to conventional induction or synchronous motors and is fitted with three-phase or single-phase winding. When the motor is running at synchronous speed, the hysteresis material is in constant state of magnetization. A special feature of hysteresis motor is the production of nearly constant and ripple-free torque during starting. Hysteresis motors are widely used in applications where very smooth starting is required.
For a hysteresis motor, there are a few applications where it is permitted to use the motor. When finding an application for a hysteresis motor, it is important to know that their efficiency must be reasonably low, as these applications are restricted to small motors. Great uses of hysteresis synchronous motor would be in such applications like clocks, tape recorders, and record players. It is known that the rotor in the motor is a smooth material that generates a remarkably low noise and vibration. Since there are no pole faces or saliences, the magnetic path is of constant permeability, which eliminates the magnetic pulsations, which are usually the main cause of noise in salient pole type. That's all I have to tell you about hysteresis motors. Thank you.
Scott and Craig made some great points about the pros and cons of those two motors, but there are many different types of AC motors, and they all have applications in which they are meant for. We only focused on two that would cover a wide variety, and that's why we chose the capacitor run start and the hysteresis synchronous motor. AC motors can be found in most applications because of the low cost and speed flexibility, and that about wraps things up from here down in the basement. Next group, you're up.